Alright, good day everyone. It's time for mathematics. We'll be checking out simple equation and variation. Okay. Meanwhile, before we go into any question to start solving, let's take a quick look at the terms used in a simple linear equation. For instance, we recognize this as an equation which is made up of 9x plus 6 equals to 34. Okay, so let's check out the parts. What are the terms that are used in linear equation? It's important to take note of these terms so that it will be easier for you to understand when those terms are used to describe certain feature of a particular equation. Okay, so we have 9x plus 6 equals to 34. Now in this equation as it were, the first term that we'll be checking out here is x here. X here is a variable. By variable we mean any alphabet that you find in any equation. Now, when it's called variable, it's simply saying that that alphabet can bear any value. It can be 0.1, it can be 1, it can be 3, it can be -5, it can be 6, it can be 3/4, it can be any value. So that's why it's a variable, meaning that the value varies. Yes, depending on the role is playing in that equation. Right? So that being said, let's check out another part of this equation, talking about a constant. A constant refers to numbers found in an equation. Now, a constant can stand on its own. Any number you see that doesn't have alphabet is simply a constant. Of course, it's a constant. Yes, meaning that value, 6 is 6. 6 doesn't change. You can't say 6 in some cases is 11. No. If it is 6, it is 6. If somebody say is giving you 6 oranges, it's 6 oranges. You are not expecting it to be 5 oranges. So that's why it is called a constant. Yes, those values without alphabet, they are constant. Right? So now, that being said, we have 6 and 34 here as our constants in this equation, right? So now another thing we need to take note of is, you can see I didn't mention 9 the other time I was talking about constant. Now 9 in this case, even though 9 is a constant, but because of its position, it is beside an alphabet, the alphabet that we call variable. Because of its position, we call it coefficient. Now a coefficient is a number beside an alphabet in an equation. So when you have a given equation and there is a number beside the alphabet, that number beside the alphabet, which you can call a constant, but because it's beside the alphabet, we refer to it as a coefficient of that alphabet. Like in this case now, I can clearly or simply say 9 is the coefficient of x. 9 is the coefficient of x. Alright, so that being said, another thing we need to take note of is when you have an equation has two parts. Yes, now the demarcation is the equal sign. So after the equal sign, you have terms by this side, you have terms to the other side. Now, when you have terms by your right hand side, I mean the terms you have by the right side of the equation after the equal sign, we refer to them as being the right hand side of the equation. That's why you have RHS. Yes, right hand side of the equation. Right? So now, when you have it towards the left, we call it the left hand side of the equation, LHS. Okay? Alright, that being said, other things we need to take note of is the fact that in an equation, there's something we refer to as term. Yeah, term. Now, term refer to each of the item in a particular equation. For instance, 9x here is a term in this equation, plus 6 is a term in this equation, 34 is a term in this equation. Okay, 9x, 6, 34, they are term in the equation. Of course, we use the understanding of term to name expression, and we use it to also name equation. All right, so we'll leave that as it is for now. Meanwhile, I would like us to also take note of one last term: root or solution of a simple equation. Root or solution of a simple equation. Or when you say root or solution of a simple equation, you are referring to what you will get after solving the equation, the answer that you have. For instance, if we solve for x in this equation, what we have as an answer, that is, when we get our final answer as x equals to something, whatever that x is equals to is our root or the solution to the equation. So this is our root. When you solve this, is our root, or we can call it solution of the simple equation. Checking out this question. Solve the equation 3x plus 4 minus y over 3 equals to 5y over 2. Okay, now there are several ways of solving this question. Of course, you can decide, by the way, to convert or simplify. Let me use the word simplify the whole of this left hand side to a single fraction. Of course, at the end of the day, you get a single fraction, then cross multiply. Meanwhile, I'm going to be taking this through a different route. Okay, also I'd like to mention to you, even though we want to use a different method, one thing that you must never do is to say you want to cross multiply here. Cross multiplying here is very wrong. Yes, it's very wrong. It's very wrong. Okay, so instead, the right thing to do is, using the method I just stated, you can just simply find the LCM of all the denominators. If you look at this very well, we have a denominator here 3 and another denominator here 2. So what do? We find the LCM of all the denominators. Okay, we multiply through by the LCM of the denominators, that is 6 in this case. So what do next? Then we multiply through, meaning that 6 is multiplying everything. 6 multiplied by 3y, that's why we have it here. 6 multiplied by 4, that's why we have it here. 6 multiplied by minus y over 3, that's why we have it here, equals to 5y over 2 multiplied by 6. Okay, so at this point, the next good thing you can do, of course, you simplify what can be simplified. You look at this very well. 3 here 1, 3 here 2, now 2 here 1, 2 here 3. Okay, so that being said, of course, that means you have 3y times 6, which is going to be 18y, and 4 times 6, that's going to be 24, and minus y times 2, that's minus 2y, and the last one here, that's by the right hand side, we have 5y times 3, that will give you 15y. Now the next step after this is to collect like terms. Of course, you rearrange. If you're rearranging this, that means plus 24 is coming to the other side. Plus 24 is coming to the other side. That's why we have it. It's coming here. Okay, and then 15y can come to this side. And you know, when plus 24 is coming to this side, it becomes minus 24. And when 15y is coming to this side, it becomes minus 15y. Even though another way to view such is noting that you are simply, number one, subtracting minus 24 from both sides, and you are simply subtracting 15y from both sides too. Yes, that will balance up the equation. So meanwhile, you can just view it this way. As they cross the equal sign, their sign also changes. Okay, so that being said, of course, if you simplify this further, that means your y equals to minus 24. That's 18y minus 15y, that's 3y minus 2y. That will automatically give you y equals to minus 24. Okay, so we move on. Let's take a look at another question here. 1. Solve the equation 2 over 5 bra x minus 2 ket minus 1 over 6 into bra x plus 5 ket equals to 1. Okay, all right. So from what you have there, of course, the first thing is to state the question the way it is, which is what you already have here as it is. And from here, the first thing is knowing that what you have here is the same as saying you have 2 into x minus 2. Okay, so what do? We can first of all expand that. So meaning that 2 multiplying x and 2 is multiplying minus 2. Okay, so 2 times x will give us 2x minus 4. Okay, you can expand this one too. Now I did something here. I expanded this one without doing anything with this sign. Yes, it's one of the safe way to solve this question. You can decide to use the sign also, but if you're using the sign, that means you have to consider it in your next operation, knowing that you have already used the sign. Right? Okay, maybe I'll cover this later. So the reasonable thing or the simple thing to do here is multiply everything in the bracket here by 1. So if you multiply by 1, you have x plus 5. Your negative is still there. Okay, so that being said, the next thing is, of course, using the methodology that we apply in the other question. The aim is this: whenever you have a fraction in an algebraic fraction like this, whenever you have a value at the denominator, one of the safe way or the simple way, it's not the only way to solve it, is eliminating the fraction so that you can see all the numbers as whole numbers. You don't have to worry yourself about the fraction part, or you don't have to worry yourself about the fraction part of the whole equation. Okay, so let's multiply through by the LCM of the denominators. You know, this is 1 over 1. There's no value there. Of course, 1 is there. So if you do the LCM of all this denominator here, it is still going to be 30. So if you have it as 30, then let's multiply it by 30. This by 30, this by 30, and what is at the other side by 30. So the next thing, 5 here, 1. 5 in 30, that's 6. So also here, 6 here, 1. 6 in 30, that's 5. So that gives us the next value. Meanwhile, whether the value is here or is here, once it's outside the bracket, it's still multiplying everything. Now, I did something here, I brought the 5 here. It is still the same thing. Okay? So that being said, from what you have here now, you can just simply expand the bracket. 6 is multiplying 2x, and you also know that 6 is multiplying minus 4. Okay? And also, minus 5 is multiplying x. Now, don't forget here, this is where you have to be very, very careful, because you have a negative sign here. It has to cut across everything. So the minus 5 is also multiplying everything here. So now let's go ahead and expand it. That means we have 12x minus 4 minus 5x minus 25. That's minus 5 times x, that's minus 5x. And minus 5 times plus 5, that's minus 25. All right. For the next thing, of course, you collect like terms. Or minus 24 and minus 25, we go to the other side. Now, if we have that way, that means we have the next thing. 12x minus 5x will give us 7x, and a 30 plus 24 plus 25 will give us 79. So from there, if you divide both sides by 7, that means you have 7x over 7 equals 79 over 7. So if you simplify further, you have x equals to 11 whole number 2 over 7. Okay, if any of this is not very clear to you, you can simply just replay this part so that you can have a better understanding. All right. Now, let's take a look at what problems involving simple equation. Okay, so from what we have there, the sum of two numbers is 25. One of the numbers exceeds the other by 9. Find the numbers. Okay, what we do is, if you are to find the two numbers, we have been provided with a lot of clue in the question. We were told that the sum of the two numbers is 25, and also one of the number exceeds the other by 9. Okay, so meaning if one number is a, the other one will be a plus 9. If the first number is b, the other one will be b plus 9. It means whatever the first number is, the second number, the other number, is greater than it by 9. It means it is more than it by 9. It means it is higher than it by 9. So what are we saying in essence? It means if the first number, let's say we pick the first number to be x, it means then the other number is equals to x plus 9. And if that is the case, from the first statement, the sum of the two numbers is 25. So we can simply interpret that sum of the two numbers is 25. So meaning that when you add the first number and you add it to the other number, the sum will give you 25. So which means 2x plus 9 equals to 25. If you simplify this further, x plus x will give you 2x. Okay, so from what you have there, if plus 9 come to this side, you know that the sign will change. It becomes minus 9. So that means you have 2x equals to 16. If you divide both sides by 2, because that means you have 2x over 2 equals to 16 over 2. 2 here, 1, 2 in 16, 8. So that means your x is equals to 8. Now, let's take a look at another question here. The length of a rectangle is twice its breadth. If the perimeter is 72 meters, find the length and breadth of the rectangle. Okay, now looking at this question, of course, a lot of factors have been provided. Length is twice its breadth. So meaning that whatever the breadth is, don't get yourself confused, but length is twice the breadth, meaning that length L is equals to 2 twice the breadth. That is 2 times the breadth. Are you getting that? Okay, all right. So it's 2 times the breadth. 2 times 2 times the breadth. That's what that statement means. Don't confuse yourself and say, oh, it's 2L equals to B. No. Of course, by definition, you know length is always greater than breadth. And apart from that, the statement as it is meant to be interpreted that way. So if they say something is 2 times the other, it means that that thing is going to be double of that other thing. Okay, now they not say that if the perimeter is 72, we are given perimeter here as 72 meters. then find the length and breadth of the rectangle. Okay, so now if the breadth of the rectangle is x, so let's say the breadth is x, that means the length will be 2x based on what I just interpreted here. Okay, so then perimeter from the question they said is 72, and you know the formula for perimeter is 2 into L plus B. Okay, so then the next thing is to slot in all the values. That means the perimeter, which is going to be 2 into L plus B, that's 2 into L, which is 2x. L is 2x and breadth is x. Okay, so if you replace it by this, then this will give you this. Okay, so from this you can then say, of course, from the definition, perimeter equals to 72. So that means everything you have here, everything will be equals to 72. Okay, so having that in mind, that means you can then expand further. Of course, 2x plus x can be simplified as 3x. I mean, when you add it together. So that means you have 6x equals to 72. And x, if you divide both sides by 6, what do you have? That means you have 6x over 6 equals to 72 over 6. Because at the end of the day, what do you have? That means your x is equals to 12. It's as simple as that. Plus 6 here, 1, 6 and 72, that's 12. If you have any question on this, if it's not clear, you can simply go over the video again. We'll be taking the journey further by checking out a change of subject of formula. Change of subject of formula. Of course, by definition, a formula is an equation which specifies how a number of variables relate with each other. Of course, we have been hearing the word variable before now. We know variable, most times we represent them by alphabet. So when you have a formula, the variables in that formula, they relate with each other. So the formula shows the role of each variable. It shows the definition of each variable. It shows the character of each variable in the formula. Alright, so that being said, we should also check the word change of subject of formula. Now, the subject of any particular formula is the main thing that other part of the formula is equal to. Okay, so it's a variable that is expressed in terms of, now I need you to take note of this word, in terms. So when they say express something in terms of another thing, it means that the whole of that thing must be equal to that thing. Okay, so in terms of other variable, examples are, of course, you know, we have v squared minus u squared plus 2as. This is from equation of motion. We have v equals to u plus at. That's another example. We also have a formula for area. So we have a equals to square root of s into s minus a, bra s minus b ket, bra s minus c ket. So you can see in each of these cases, we can say something that v is the subject of the formula here. V, of course, v squared is the subject of formula here, v is the subject of formula here, and a is the subject of formula here. There are many other formulas, like when you say that density d can be taken to be m over v. It's also a formula. So in this case now, d is the subject of the formula here. In some cases, you can say v equals to IR. In this case, v is the subject of the formula. You can say a equals to length, that's L times b. In this case, a is the subject of the formula. So we have many formulas. So what we'll be checking out under this is how to manipulate, how to work with formula such that when you need a particular value to be the subject at any point in time, you can easily sort that. Now, by subject of formula, at times, even though V is the subject of formula in this place, even though V is the subject of the formula in this place, you can decide to make A the subject of the formula. You can decide to make T the subject of the formula. You can decide to make U the subject of the formula. Now, those are the simple things we will be checking out in the next few minutes. So I need you to take note of every principle that we'll be applying, because the principle is general in all cases. You just need to know and note the order with which they are meant to be applied. Okay, so now let's take a look at this. Make the alphabet in front of the formula in bracket as the subject of the formula. What we are saying in essence is that for the first question here, we are making X the subject of the formula. This is what we are making the subject of the formula here. In this place, we are making A the subject of the formula. In this place, we are making Z the subject of the formula. Okay? So, from what you have here, let's check it out one after the other. Okay? Alright. So, we have a first one being mx minus nx equals to 5. We are making x the subject of the formula. Now, one beautiful thing, one simple thing that you can do here when you have something like this is you need x. X is what you need. You don't need n. And the good thing for us, x is common here, x is common here. So what do? We can factorize out x. We can factorize out x. Alright? By our methodology of factorization, it means x is common here, is common here. You can bring it out. So if you factorize out x, that means x, this will give us x into, that's bra m minus n ket. Okay? Alright? If you're confused as regarding how we come about this, or when you're factorizing, you have m x minus n x. So factorizing means x is common, so you are bringing out x, so you are also dividing through by x. You are dividing through by x. So if you do that, of course, you know that from here s cancel x, s cancel x. So from here now, the next thing is x is a product of m minus n. So the reasonable thing to do is to discard out m minus n that we don't need here. What do? You divide both sides by that value, m minus n. By that, we have done justice to it. In this case, we know that m minus n cancel m minus n. So that means x will then be equal to 5 over m minus n. That is the answer to that question. Okay? So, we can then go ahead and solve the second question. Alright? Now, let's take a look at the second question here. We want to make A the subject of formula. Now, because A is hidden under the square root, it means the first thing we have to do is to take away the square root. And the only reasonable way to take away the square root is by squaring both sides. So squaring both sides means this will have square. It means these two we also have a square. Okay? Alright. So if they both have square as stated there, of course that's the next step. So it shows you that this r square, this r square. And like I said, the objective is to remove the square root. And the only way is to find the square of both sides. So when you have a particular variable that you're trying to make the subject of the formula inside a square root or a cube root or a fourth root, either of the case, of course, you have to use a power that can properly annul or remove such root value from the part of the expression. Okay, so now from here now you can conveniently say square will cancel square root, so we are left with this square equals to h over a minus 2. Now don't forget, what we are interested in is a is what we are making the subject of the formula. Okay, so the next thing of course to do here is to cross multiply. If we cross multiply here, what do we have? We have this square multiplying a minus 2. Don't forget, it's a that we are interested in. So we find a way. The objective is to separate minus 2 away from this expression so that we can have a standing alone. So from here, now one good thing we can do here is we need to take care of this. Of course, there are two ways to solve this. It's either you expand the bracket, or the other option is to divide both sides by this square. So I'm dividing both sides by this square. It's one of the simplest way to sort this out. You divide both sides by this square, that means you have this square cancelling this square. So we are left with a minus 2. So a minus 2 will be equals to h over this square. Now don't forget, what we are making the solution of the formula is a. So meaning that we can simply say a equals to h over this square plus 2. Of course, that's by taking 2 to the other side. And we know the sign will change from negative to positive. Okay, so that being said, we can say we have our final answer. Okay, now let's take a look at this. Now the first thing is, of course, because z, we are making z the subject of the formula, so meaning that we have to take away the covering from it, which is the square root. So we square both sides. If we are squaring both sides, what does that tell you? It means y square equals to square root of square of the square root of 1 over x minus 1 over z. In which case, you know, you all agree with me that square will cancel square root. Okay, so if it cancels each other like this, so that means we have y square minus 1 over x equals to 1 over z. And don't forget, z is what we are trying to make the subject of the formula. We're trying to make z the subject of the formula. So we're making it the subject of the formula. One of the good things we can do is, number one, you can find the LCM of x and z. Of course, LCM of x and z is xz. So xz divided by x will give us z. That's z times 1. That's why we have z here. Okay, and xz divided by z is going to be x. So x times minus 1, that's minus x. Okay, so that being said, then we can then cross multiply. So if we cross multiply, this will give us this. Of course, from what you have here, you know, the next thing to do is, of course, our objective is making z the subject of the formula. So one of the things you can do is try and bring all the z together. Everything that contains z, you bring them together. So that means the logical thing or reasonable thing we can do here is what? We bring z to this side. Okay, so if you're taking it to that side, that means of course it changes to minus. And from here, the good thing is we need z, and we have just a single z here, and we have another single z here. So what do? We can just simply factorize. So if you're factorizing this, of course, you factorize z out. That will give you this. Okay, so from what you have here now, z is out, is separated from the rest. The only simple thing that you should do at this point is you divide both sides by x y square minus 1. Xy square minus 1, you use it to divide both sides. So from here, you can relate with the next thing. This will cancel this. And what are you left with? Z equals to minus x over xy square minus 1. That is your final answer. By definition, variation can be defined as the relationship between two or more quantities in which, when one quantity changes, the order or orders changes as well. What we are saying in essence is that in variation, quantity, when we say quantity, we're talking about amounts of certain things, like time is a quantity, distance is a quantity, speed is a quantity. Let me also use this, for example, the size, of course, of your tummy is going to be determined at times by the amount of food that you just finished eating. If you eat small food, it might protrude less. If you eat more food, it might protrude more. But if you eat less food, it protrudes less. That means the amount of food you take determines the size of your stomach. And in turn, it also affects the number of times you visit the toilet. Okay? Alright, that's just by the way. Meanwhile, I'm only trying to explain the concept here. In variation, one quantity, once it changes, it affects the way others changes too. I mean, for instance, for a person that is moving from one point to the other, as the distance is changing, the time spent to move from one place to the other too is changing. Okay, so that's why where a person will be when he move for 1 minute is not the same as where a person will be when he move for 2 or 5 minutes. Okay, so also we should take note of the fact that we have different types of variation. Of course, the first one is direct variation, we have inverse variation, and we have joint variation, while the last one is partial variation. So we'll be taking a look at each of all of these one after the other. Now let's take a quick look at this question we have here. Direct variation. Let's take a look at it. They say if P varies directly as R, that's the way it's pronounced. P varies directly as R. In certain contexts, you might just be told that if P varies directly as R, or if P is directly proportional to R. I'm just giving you the forms that you might have the question relate to you. Okay, so if P varies directly as R and P equals to 100 and when R equals to 25. Now, in a typical variation question, we know that by definition, if P is directly proportional to R, to the other form of this expression is by writing it as equation. So we're going to write it as equation. It means that it will be P. Our variation sign here changes to equals to K. Yes, it changes to equals to KR. So by definition, this is what this implies. So when you want to change from the variation format to equation format, you say P equals to KR. Alright, so now that being said, now in most cases we will always be given some set of value, and the reason why we are given those set of values is so that we can find the value of K. So we call those set of values, we call them initial values. Yes, initial values, because without the initial values we will not be able to find K. K is a part of the equation that is a constant. We call it constant of proportionality. Constant of proportionality. Okay, so from what we have here, what you need to do is slot in the value of P and the value of R into the equation here. So if you check it very well, it means this equation will translate to this because P is 100 and R is 25. Okay. So this will give us 100 equals 25k, and of course if we divide both sides by 25, you have 100 over 25. So our k is 4. Now the first question, as stated here, you can see it says that the relationship between P and R. Another word that can be used is you can be asked to just state the formula connecting P and R. It's still the same thing. So the relationship between P and R is this formula here without K being there. Now, and if K is not going to be there, you have to replace it with something that is meant to be there, which is the value of K. So that means this is supposed to give us what? That's a K. The relationship between P and R is going to be P equals to 4R. The relationship between P and R is P equals to 4R. So it's a formula connecting P and R. So that being said, we can then go to the B part of the question and say find the value of R when P equals to 400. So what you're just expected to do is you put in place of P 400. You know the formula. This is the formula, and from what we have here, we know our K to be 4. We know our P to be 400. So that means we have 400 equals to 4 times R. So from what you have there, we can say our R equals to 400 over 4. So R is going to be 100. It's as simple as that. Alright, now let's take a look at inverse variation. So we'll be checking out a question. Now, y is inversely proportional to x squared when y equals to 8, x equals to 2. What is y when x is equals to 3? Of course, the first thing we need to take note of here is the interpretation. The first thing for us to take note of here is the statement inversely proportional. And for us to get used to the context it's used, they say y, or let me say I'm saying A is inversely proportional to B. That means A is inversely proportional to B. That means A is proportional to 1 over B. Is the same thing as that. A is inversely proportional to x squared. It means A is directly proportional to 1 over x squared. That's what that statement means. Okay, we need to take note of that mode of interpretation. So that being said, look at this question. Y is inversely proportional to x squared. So if y is inversely proportional to x squared, it means that we can, of course, we know what to do. We want to change it from the variation form to the equation form. Okay, so meaning that our proportional symbol here will change to equal to k over x squared. It means our proportional symbol is going to change to equals to k over x squared. K will be at the numerator. It will be with whatever you have at the numerator. Okay, so the proportional sign changed to equals to k over x squared. So the k will always be at the numerator. Whenever you want to translate from variation form to equation form. Okay, so from what we have here, we are given initial value as usual. You know, the former question, at times you might be asked the question following after each other, like find the equation connecting y and x squared. But in this case, they didn't ask us, but you will always need it. And that's why, in any case, few things that are very important. Number one, the mathematical representation of your variation statement. Number two is the value of k, which you have to always take note of. Alright, so that being said, so we're given initial value for us to find the value of k. So if we slot in the value of y as 8 and value of x as 2, so you have 8 equals to k over 2 squared. So which is going to be equals to, of course, you have 8 equals k over 4, which if you go ahead and just cross multiply, your k will be 32. Alright, so from that we have our equation connecting y and x squared. So that being said, meanwhile, the question said that we should find the value of y when x is equals to 3. So when x is equals to 3, just slot in the value of x there. So which is going to be 32 over 3 squared, 32 over 9, which is 3 over 5 over 9. In joint variation, we are simply talking about something varying with respect to more than one quantity. It can be two quantities, it can be three quantities. For instance, you will say x vary jointly as y and z. In that case, x varies directly as y and x also varies directly as z at the same time, and that's why it's joint variation. Also, if you're talking about x varies directly as y and inversely as z, that is what we're going to have. In this case, x varies directly as y and it varies inversely as z. So in any case, looking at this third scenario, where in any case more than one quantity is involved, it means the main quantity varies with respect to more than one quantity. In some cases it can be 2, in some cases it can be 3, but irrespective of what it is, it can still be referred to as joint variation. Look at A varying jointly as B, X and P is a form of joint variation. It's involved more than one or two or three elements. The first thing is to write the statement. On the statement, you can see B varies directly as C and inversely as cube of D as expressed. From what you have there, you know the first thing to do is to rewrite it as equation form, which is B equals to KC over D cubed. The symbol of proportionality get translated to equal sign and constant of proportionality, which is K. Meanwhile, it's worthy of note that in any question you will be needed to find your K. Your K is very, very important, and that's why you are given all the initial values that you have been given. Okay, so we are to take note of that. So slot in the values. After slotting in the values, of course, that will help you to find your K. So if we solve further, we can so at the end of we divide both sides by 5, so K is going to be 48 over 5. So meanwhile, the question says find D in terms of B, find B in terms of C and D. Simply, you have to replace the value of K in the original equation. So if we replace it by that, we have our final answer. So from there, of course, if any part of this is not clear to you, you can just go over it again, replay as much as possible. I know it's going to help you to understand everything. So make sure you check out the assignments also. Okay, thank you.